Hello student, welcome to Vidyanest. In this revision class, see, let's start with this problem. See, the problem is clearly visible that it is related to complex number.
Okay, sir.
Okay, so what does it mean? Of my modulus, I hope you can remember. Say z minus z0. It means what? Mod of z minus z0, distance between z and z0. Means if z is x plus iy and iy0, and if I subtract I will get this, and its magnitude so this reminds you the distance formula, distance between 2 points x comma y and x0 y0. So this thing also have that relation. See, mod z minus I means here mod z minus I means x plus I minus I. So it is the distance between x comma y and 0 comma 1, x comma y and 0 comma 1. Okay, so if I draw one figure, then we'll get the proper depiction. What about z plus I? Just wait. Z plus I is what? Z plus I the distance between, it is distance between this can be written as x plus iy minus of minus I. That means distance between x comma y and 0 comma minus 1. And the last one that mod z minus 1 it implies what? It implies distance between x comma y and 1 comma 0. X comma y and 1 comma 0. So let us plot it on graph. See, first 0 comma 1. Where can I plot 0 comma 1? This 0 comma minus 1 and 1 comma 0. 1, 0. Now you see the question. Here what is given? The distance see, they can form a triangle, and z is such a point which is equidistant from this point, and this point. Okay, so this point is equidistant from 3 vertices of this triangle. So you see, what is S? S is a point. Which point? That's Z. Now in this triangle, inside this triangle, how many such points exist which has equal distance from 3 vertices? Only 1 point. Okay, so because if you wish, you can consider it as a circle, that is center of the circle, 3 radius. So in a circle there exists only one center. So ns is what? Number of such points is 1. Understand? See, Z is a point which is equidistant from this point, and this point. So what kind of point is this? Circumcenter. See, if this is the center of the this is the point equidistant from each vertices, so I can say this point to be considered as the center of the circle. Okay, and this distance can be considered as radius. In a circle, how many center can exist? Only one center. So how many such points are there in this set? Only 1 point. So number of such point is 1. Got it?
Got it, sir.
Okay. So it came in 2024, looked up, but not so. See this sum. In the previous sum, I hope you don't have any other requirements. You understood the sum.
Yes, I understood.
Good. Now, how to defend or handle this sum? In this sum, we need to you need to introduce the expansion of e to the power x. How to use that? See, we know the binomial expansion and expansion of exponential. E to the power x. Expansion is what? X by factorial 1 plus x square by factorial 2 up to infinity, and 1 minus x whole to the power n, where you are getting the semblance of this formula, this expansion. Here 1 minus x whole to the power n, 1 minus nx the series will be on. So that too series will play the key role in this sum. Okay. Now,
Okay.
how to defend this? See, first of all, we will split the limit into 2 parts. Beta is equal to limit x tends to 0. How to split this part? by this and this part by this. So with this plus sign, we can split the limit into two parts. Plus, hope you could recall these formulas. So for your convenience, I am just rubbing it. Okay. See, this part plus C. Here, one sin x will be dropped, but here nothing. So we have nothing but to expand it. See how to expand. One sin x gone. And what is left? Here rationalization possible because power is half means it is square root. E to the power x cube. You just recall e to the power x's expansion. 1 plus x cube plus and this 1 minus s cube whole to the power 1/3 that can be expanded as c up to infinity. Whole thing is divided by x sine square x. Don't be confused seeing this gigantic figure. It is just nothing but expansion. So this part is written here. And what about that part? Plus c, this to the power half means square root. So it demands rationalization and just following the splitting it into two limits. Limit extends to 0. Here you see root x minus 1 rationalize. So in numerator you can observe, had this bracket been removed, then this one and this one would be cancelled. So first you cancel this part. Any other privilege? Yes. See here, at least one we could remove one. Now let's wait for the further simplification. See this part must tell me if you get any doubt. X cube, this is x to the power 6, x to the power 9, x to the power 12, minus factorial 3 x to the power 9 and so on by x sine square x. That is the first part. Second part, much more simpler. You see, root will be removed, 1 will be cancelled, limit, root will be removed, 1 cancel, x sine x, and here if you wish you can put 0. So that part will be nullified, 1 by 2 by putting x is equal to 0. Now in this gigantic figure you separate the like terms. Why? Because to ease the calculation, here x cube, x cube, x to the power 6, x to the power 6. In this way, you can put them together. Or another thing you can do, you can take x cube common from the whole expansion. If you wish, you can take x cube common from whole expansion. It will be better. Then you can avoid that, complex calculation. See, we are taking this x cube because see here in this first bracket, minimum power of x is 3 and here minimum power of x is 3. So we are allowed to take x cube common. So we have taken x cube common. What will be left in the bracket? In first bracket, 1 x cube by 2 x to the power 6 by factorial 3 and so on. And in second bracket, by x sine x. Here you see 1x will get cancelled and you will get the formula.
Yes, sir.
So the thing which seemed to us so tough has become so simple. Here minus x by sin x into half. Now here 1x will get cancelled. You will get x squared sin square x. That will again give you 1. So we are in the verge of conclusion. And in the rest of the algebraic expression, if I put x0, all terms will be 0. All terms will be 0 apart from these two, 1 and minus 1/3. So this will be 1 square. So take the LCM, 6, 5 by 6. Now you observe, you see, you are told to find what? 6 beta. So this value is equal to beta. Beta is equal to 5 by 6. So 6 beta is equal to 5. Got it?
Got it, sir.
Just go through this trigonometry. Looked very big, very complex, but there is simplicity hides behind the screen. See, what is given? Alpha, beta real numbers, where beta lies between minus pi by 4 and 0, 0 less than alpha less than pi by 4, sin alpha plus beta is 1/3, cos alpha minus beta 2/3. You are told to find the greatest integer less than or equal to this. Actually, its value you are told to find is integral value. Let's see how to simplify. Just 1 minute. First of all, you club the number in this way. See, I think these two and these two will be taken in pair, because in these two, in both case, sine and cos angle is same, beta, and here in both case angle is alpha. So better to put them together in that manner. Let's try with this approach. If we don't get, then another approach. If I put myself in your position, I would have tried it this way. Let's see whether in that trick we'll find the solution or not. So we have nothing but to take the LCM and see the outcome. Sin beta, cos beta. See this part and this part. Sin alpha, sin beta plus cos alpha, cos beta plus here also you see cos alpha, cos beta plus sin alpha, sin beta. Okay, one mistake.
Oh,
What mistake? Here alpha and beta, two different angles. By mistake I have written sin alpha, cos alpha, that is. Now this formula, the numerator part, reminds us the basic formula cos A cos B plus sin A sin B, that is cos A minus B. No change in denominator. And here also the same thing, cos A cos B plus sin A sin B. So in OpenEye, what seems to us common from numerator? Cos alpha minus beta. Yes or no? Cos
yes.
alpha minus beta. So take it common. If so, and it will be brought out of the bracket in terms of whole square, because you know the power of this expression, highest power is 2. Now, after reaching this stage, we have to examine that does this expression, does this expression has given us any clue to finding the conclusion? Let's see the question. Cos square alpha minus beta, yes, there is a semblance of simplification. Cos alpha minus beta is given. So cos alpha minus beta 2 by 3 you put. So one step, one layer of simplification is done. Now this formula where sine and cos both have same angle will remind you what approach of trigonometry, multiple angle. Sine 2 sine theta cos theta sine 2 theta. You are taught 2 sin theta cos theta. See, in both cases, angles are same. Sin to theta. So, but 2 is missing here. So, multiply numerator and denominator by 2. That will give you what? This is 4 by 9, 2 multiple angles property. Now, these 2 will be brought out of the bracket in terms of 4 because its power is 2. So, it has become 16 by 9, 1 by whole square. Now, after reaching this stage, we have to give a pause. Why? After that, what to do? We will do simple LCM, or is there any other trick we have to examine? Let's see what terms are given. Sin alpha plus beta is given, cos alpha minus beta is given. So there are both terms exist, alpha plus beta and alpha minus beta, both. So that denominator's angle to be expressed in terms of both alpha plus beta and alpha minus beta. So instead of 2 beta, instead of sin 2 beta, you can write sin alpha plus beta plus minus alpha minus beta. Why? Because if you remove the inner brackets, you will get back 2 beta and 1 by sin So we could reach up to this stage. Now, how to proceed? Now we have to take the LCM. We have to take the LCM, no other way. See, now take the LCM. Sin So we could reach up to this stage. See, the numerator part is so simple, it will become 2 alpha, this is 2 beta, as you had in the previous to previous step. But what is denominator? What formulas? What formulas recalling is required. See, I am just reminding you one formula. Sine A plus B into sine A minus B, sine square A minus sine square B. That is, one basic level property of trigonometry which you are taught at the beginning of your session. Just wait.
Okay, sir.
Sine A minus B, sine A plus B. Now we are in the position to conclude the sum. The sum is really gobsmacking, which will put you in confusion. But if you have that confidence, okay, I know all this formula, so if I keep on proceeding the proper use of the formula, once I'll be able to terminate successfully. Obviously, you can do that. Sin C plus sin D, 2 sin C sin square alpha plus beta, sin alpha plus beta 1/3, cos alpha minus beta 2/3. Use their value. This is sin squared, so 1 minus one by 9 cos alpha minus beta 2/3, 4 by 9. Sin alpha plus beta is what? Sin alpha plus beta 1/3, cos alpha minus beta 2/3. Sixteen by 9. Okay, so at the beginning the sum was too tough, yes or no? At the end it terminates to a simple form. Yes or no?
Yes, sir.
Just wait. Let us see this sum. It came in JEE Main. The sum is related to binomial theorem. Just wait. See, in every year, in if you choose one paper of any shift randomly, you will find this level of sum, this type of sum. It came in C, June 24, 25, 2022. In so many shift it came. Until 2022, 27, 28, 26, 24 in different shift, the sum came. Looked
Okay,
very
sir.
tough. It cannot be done by any conventional method, but if you use binomial, the toughness of the sum will be withdrawn. First of all, you have to observe that you are told to find the remainder when it is divided by 5. So you express 7 and 3, 7 and 3 both by 5. 7 means 5 plus 2 whole to the power 2022. 3 means 5 minus 2 whole to the power 2022. Now expand it. The first, expansion is expanded in this way, and second one, see, I forgot to write 2 over here. So if you remove the bracket, if you remove the bracket, you see all the term, odd number of terms will get cancelled, and you will get twice event terms. So we have got this thing. Okay. Apart from the last term, all the terms containing 5. So barring the last term, the other terms will be divisible by 5 because
Okay, sir.
okay, all terms are somehow generated by 5. So 2 into the terms in which 5 exist, I can take 2 into this part will be apart from the last 5k plus this is what 1 2 to the power 2002. 1 minute, just hold on. Oh, 2022. Mistake. Now, this part, this part is left. So can I tell that this part is the remainder? No. See, this is multiple of 5. Now what about this? So there is a shortcut trick in finding using Fermat's principle. See, see, 2 square, if you divide by 5, it is called modulo. Remainder is -1. 2 square when divided by 5, remainder is -1. Now you take 1011 power to both sides. Just 1 minute. See, 2022 -1 modulo 5. What does it mean? You are dividing by 2 to the power 2022, remainder minus 1. So by the division algorithm, what is the exact remainder? If you get like suppose you are dividing say 9 by 5. 5 2s are 10. You are getting the remainder minus 1. But is it the actual remainder? No, because 5 will go only one times. So remainder is 4. By adding this, you will get the remainder. So in this case, remainder is 5 minus 1, 4. See, the first part divisible by 5, so there is no question of remainder. And second part, if you do with Fermat's law, you will get remainder 4. So remainder is 4. Option D correct. Okay.
Okay, sir.
See this sum. A normal to the hyperbola has equal intercept on positive x and y axis. First of all, in tangent, slope is dy dx. So in normal, slope will be minus dx dy. So you differentiate first. If you differentiate, you will get what? Okay. So 2x by 4 2I dy dx. Now 2 cancel. So what is dy dx? X by 4y. Now we have to find the normal. So it is slope of the tangent. That is slope of tangent. Slope of tangent. Then minus dx dy. That is 4. So at x1 y1 normal, what equation of what this is? Hyperbola. Equation, then at x1 y1 normal, so at the beginning we can reach up to this stage. Just wait, I'm coming, just wait for a while. Now this is slope, normal slope of normal is at x1 y1 is this. Okay, up to this stage, no doubt.
No doubt.
Now what is the equation of the slope? See, that is the curve. So equation of normal to the hyperbola is y minus y1 minus 4y1 by x1 x minus x1. Okay, normal straight lines equation. Yes or no?
Yes, sir.
Now we have got okay. Yes or no? That is the equation of the normal. Yes or no?
Yes.
No toughness is there. Now, in straight line, you were taught that any equation can be expressed in intercept form. X by A plus Y by B, 1. This is A, this is B. So, I can express it in terms of intercept form. Divide both sides by this. So, X by okay. So, we are able to express it, the normals equation in terms of an intercept form. Understand?
Understood, sir.
Now, the question is what? What is the requirement of expressing it in terms of intercept form? You just, semblance is given in the question. You see, as equal intercept on x and y axis. So, those intercept must be same. Hmm? According to the problem, according to the question, this is x-intercept, this is y-intercept, they must be equal. Yes or no?
Yes, sir.
5 x1 by 4 is equal to 5y1. X1 is equal to 4y1. Now, what is the use of this result? See, that x1, y1 point which I have taken, it must lie on this hyperbola. See, x1, y1 points on which you are finding or you found the normal lies on hyperbola So x1 by y1 will satisfy the equation. X1 is what? 4y1. So 4y1 square, 16y1 square by 4, y1 square plus minus 1 by root 3. No, it lies in the positive direction of x and y axis. So I will take only 1 by root 3. Yes or no?
Yes, sir.
So once you get y1, that means x1 is what? 4 by root 3. So the point at which the normal is drawn is found. The point at which the normal is drawn on the hyperbola is found. That will be really helpful to terminate the sum. Therefore, equation of normal to the hyperbola at x1 y1 is, see, earlier you got what? Equation of the normal. Did we get? Hope so. That was the equation of the normal. Yes or no? X1y plus 4xy1 is equal to 5x1y1. X1y plus 4xy1 is equal to 5x1y1. Okay. Now x1 is what? Y1 is what? 5. So what simplification is waiting for us? I can take 4 common. X plus y by root 3 is equal to 5 into 4 root 3 into root 3, 4 cancel, 1 root 3 cancel, y is equal to minus 1x plus 5 by root 3. That is equation of the normal. Yes or no? That is the revised equation of the normal. Okay.
Okay, sir.
Now that normal touches the ellipse. Which ellipse? That ellipse. Now this normal touches the ellipse. One. What is the condition of tangency? Y is equal to mx plus c be tangent to ellipse. So here c is what? 5 by root 3. A square. What is A? A itself. M square plus B square. So A square plus B square is 25 by 3. Understand? Got it?
Yes, sir.
Now,
Got it.
yes, we are in the verge of conclusion. We are told to find what? Just looking at a glance. We are told to find 9 by 25 A square plus B square. We are told to find 9 by 25 A square plus B square, and A square plus B square's value we got what? Just now 25 by 3. Just plug this value and put 9 by 25, 25 by 3. Answer 3. Does it match with any option given above? Yes, it matched with option C. Okay. See this sum. Two ellipses are given. You are told, and their product of their eccentricity is also given. You are told to find the length of minor axis of the ellipse. So, I think it is simple approach, not that much of tough. Equation. First equation's eccentricity we will find. See, I'm letting eccentricities of the first ellipse E1, that is root over of 1 minus, see here a square is greater than b square, so not conjugate ellipse. 1 minus b square by a square. 1 minus b square is what? 2 by 3, 1/3. Now E2, b square by a square, and the product is given half. Now square both sides. So b square is 4. Now length of minor axis. So once you get b square 4, therefore b is 2. Now once you get b2, mean b square 4, obviously here also a square is greater than b square. So b will be the semi minor axis. So length of minor axis 2b is equal to 4. Does it match with any option? Yes. Option B correct. Okay.
Okay, sir.
See this sum. This is a binomial expansion. Multinomial or trinomial you can use. You are told to find the coefficient of x to the power 4, y to the power 10, z to the power 3. Okay. Frequently this sum students are facing in JEE exam. I'm just reminding you the basics of finding binomial coefficient in this type of expansion. See, just I'm reminding you, say x1, x2, x3 up to xm all to the power n. In case of simple binomial, easily you could have found the coefficient of any term, but it is multinomial. More than two terms are there. So we went through this property. See P1, P2, P3 up to Pm, where x1 repeats P1 times, x2 repeat P2 times, x3 repeat P3 times, xm repeat Pm times, where sorry, so that is the multinomial theorem's expansion. Now here, how does it help us? It is clear approach. See, instead of x1, x2, x3, xm, x, y, z, n is 17. So I can write summation of factorial 7. See, here it is x1 repeats p1 times. So x repeats 4 times. Factorial 4. y repeats 10 times, factorial 10, z repeats 3 times, factorial 3, x to the power 4, y to the power 10, z cube. So this is the coefficient. Does it match with any option? C. Straight approach of multinomial theorem. Understand? Option C. That is the coefficient of this. Okay.
Okay. Yes.
Just wait. See this sum. That is an ellipse. And one circle concentric to this ellipse passes through the foci and cuts the ellipse at P. So let us draw one ellipse. Two foci it has. Now one circle passes through S1, S2 and cut it at P. And area of P S1 PS2 is given 30. We have to find this. PS1 PS2 triangle. How to find it? See, first of all, we'll examine whether the figure is correct or not. A circle is concentric to the ellipse. What does it mean? It means the center of the circle and the vertex of the ellipse are same. That means that is the vertex of the ellipse and that is the center of the circle. So that must be the diameter. But this figure doesn't depict that thing. So better to draw one clear figure which can make you understand clearly. See, that is one ellipse given. Now the circle concentric to the ellipse. Now, so it is concentric to this ellipse. That means the center of the circle and center of the ellipse must be same. The circle, that means this will be considered as the diameter. Now the circle will be like this. Now how to proceed this? That is a circle which, see, difficult to draw roughly. It looks like ellipse again. This is the circle. Now it is okay. S1, S2, P, that area is given 30. Okay. Hello.
Yes, sir.
Okay. Now let us rewritten this equation of the ellipse in its standard form. X square by, you do one thing, just drag 4 in the denominator of this, and this thing what is the side note? Lambda less than 17 by 2. What does it mean? It is the ellipse with respect to x-axis. Horizontal axis is the axis, not conjugate. So major axis, actually this means this condition depicts that major axis lies on the horizontal axis. Okay. Now in class 10, you were taught one formula. What formula? One theorem in circle. I hope you can remember. Semicircle subtend 90-degree angle on the circumference. Yes or no?
Yes, I remembered.
So that basic level formula again is knocking at the door. So here the circle passes through S1, S2, and the center of the circle and center of the ellipse are same. Here the circle is concentric to the ellipse. Here the circle is concentric to the ellipse. That means center of the circle is 0, 0, and S1, S2 is the diameter. This is the diameter. Now you observe, this is the diameter. So this angle, according to this theorem, this angle is 90-degree, because in with respect to circle, S2 P S1 is the semicircle. Yes or no?
Yes, sir.
So triangle S2 P S1 is right triangle. Therefore half base into height. That means, but area of the right angle triangle you can find, but there is no such value given. 1 minute. Passes through S1, S2, S1, S2 we have to find. Okay. That is given 30. According to the question, this is 30. That means this is base, this is height. Half, I can write half S2P into S1P is equal to 30. S2P into S1P is equal to 60. Okay. So we could reach up to this stage. Yes or no?
Yes, sir.
Now, in ellipse, you were taught one property. I'm just reminding you. What property? PS, PS dash. PS plus PS dash twice A means length of major axis. Okay. Length of major axis. So, according to this figure, H2P plus S1P twice A. What is A? 17 by 2. 2 into 17 by 2. 2 cancel. S1P plus S2P is equal to 17. Understand?
Understood, sir.
Now, we have to find S1, S2. Okay. You know Pythagoras theorem? Yes or no?
Yes, sir.
Let's see how does Pythagoras theorem abide by us. It is a right angle triangle. This triangle is a right angle triangle. So, S2P square plus S1P square is equal to S1 S2 square. Yes or no?
Yes, sir.
Now in class, junior class, you are taught A square plus B square's formula. What is that? S2P plus S1P whole square minus twice S2P into S1P is equal to S1 S2 whole square. This is 17 square, and that is so S1 S2 whole square is like that. Now 17 square is 289. S1 S2 is 13. Understood?
Understood.
Now you are told to find what? Let's see. In the question, S1 S2 by 13. So is equal to 1. Answer is 1. See how good the sum is. Wonderful sum that is. Okay.
Okay, sir.
Just wait. Now this sum, how to proceed? Just look at a glance. In this sum, main problem is recognizing the series. That is the main problem. How to recognize the series? Real problem, that is just one minute. Just wait. It is this in this sum. Let's write the sum again. 1 plus it is a difficult job to find the up to infinity. There is some printing ambiguity. How to define this sum? 2686 root 3 2 root 3 whole square, how much? 12, but given 18. See, it is difficult job because the sum is, look very critical. But there is one clue. Just observe carefully. One clue is given. Root 3 minus 2, the numerator of the, you see, second term. So if I find it square, you see, it will give you 3 plus 2 minus 2 root 3 root 2. 5 minus 2 root 6. So we are getting one value. What? If this is a, this is a square. Yes or no?
Yes, sir.
Now you observe whole cube. A cube, whole cube means this thing 5 minus 2 root 6 into root 3 minus root 2. Just observe whether the third term is coming or not. If third term comes, that means that expression is true. 5 root 3, 5 root 2, 2 root 18, 2 root 12, 5 root 3, 5 root 2, root 18 means 6 root 2, 4 root 3. Sorry, there is plus sign. Yes, coming. So, this is a square, a cube, a to the power 4 like that. Yes or no?
Yes.
But what about the denominator? In denominator, we are not getting that similarity. 2 root 3 whole square, that is 12. But here it is given 18. 2 root 3 whole cube, that is 8 into 3 root 3, that is 24 root 3. But here it is given 36 root 3. Yes or no? So we are not getting that parity, that similarity which we got in case of numerator. So again that has hanged us. This sum has hanged us on tenterhook. It means 2 root 3 whole square into 2 root 3 whole square. That means 18 into 18, 144. So, but here it is, you observe, we are not getting any parity. Now, we can attempt one thing. 12 means 18 into 2/3. Now 24 means 36 root 3 into 2/3. Yes or no?
Yes, sir.
Now we are getting 144 means 180. Now here we are not getting 2/3. So again we are trapped in the same problem. 18 into 18. Hey, sorry, mistake. 2 root 3 whole to the power 4. 4 square cube 4. 2 root 3 whole square, how much? 12. 140. Mistake, but not that much of mistake. 144, that will come. But that relation we are not getting here. 144. So I think, one minute, just wait. Hold on. 18 by 2 root 3. 1 minute. 18 by 2 root 3. 9. 3 root 3. 3 root 3. 2 root 3. 5 root 3. We can take anything common. Root 3. Root 3. See, we are not getting any parity. Let's see. First, I am let this part has no use. So rub it. Let root 3 minus root 2 is equal to A. Then the above series is reduced to 1 plus A by root 3 A square by 18 plus A cube by 36 root 3 plus A to the power 4 by 180, like that. So this much simplification is done. This much simplification is done. After that, more simplification required. Just wait. We have to find it. I think telescope not possible. Then this doesn't give us any series. A by 2 root 3. A by 2 root 3. A square 2 root 3 is 12. So if I take root 3 somehow common, then what will come? There is some ambiguity in the question, I think. Just hold on. Don't. Okay. See, that is a series we have got S. But how to express it in terms of this? 1 by root 3. Just wait. A square. 180. 2 root 3. It looks like 2 root 3 whole square. It is 3 root 2 whole square is 18. That mistake is being done. So somehow it is related to logarithmic expansion. I think in this sum there is some ambiguity, okay, in printing. See, this is, it should be 3 root 2 is square. Other terms are coming. Only one terms we are getting trouble. Okay, we'll see it in later. Understood? There is one ambiguity in time of printing. Something is missing. Okay. We'll do this in the next step. Got it? Because you see, first term is coming. A with this term there is no parity in the denominator. No parity. Even it is neither AP series nor GP series. You see 2 root 3, there it has no connection. It has connection with 18 connection with 36 root 3, but 36 root 3 has no connection with 180. Means if I take if I multiply this thing whole square with 2/3, I am getting 18. Is whole square with 2/3 36 root 3, but the last part I am not getting. That has to be shown in the last day. Okay, so you leave this sum, you will redo it again in the next day. Other sums are done. Okay, so
Oh,
whatever is taught today, understood.
understood, sir.
So we'll meet with more sums next day, but obviously we'll start this sum with rectification. Understand?
Understand.
There is some mistake, I think, printing or the some data are missing. We'll see in the next class, and you can also remind me. We'll see in the next. Okay.
Okay.
Okay. So see you. Goodbye.
Thank you, sir.